Continuing to study fractions, adding mixed numbers, adding and subtracting mixed numbers in this demonstration. We're going to add one and subtract another. We're starting to mix skills because you've had a lot of practice with fractions, and now we're just kind of building on that knowledge. You should have a good foundational grasp of all the operations we're really employing here. We just have to mix operations to solve a more complex problem. Now, as you start to think about adding these two, what jumps out at you right away is that the denominators are not common, and we have to have common denominators. So we're going to have to fix that first. And I think you've seen how I like to do it. I like to draw a little line. We're probably not going to do anything to the 3 and the 2. They're probably going to stay the same. For now they are anyway. We may have to manipulate them later, as we found out. But let's go ahead and change 1/3 and 1/4, and we want to find the least common multiple of those, and maybe it jumps out at you right away and you see it as 12. Maybe you have to list the multiples: 3, 6, 9, 12. Doesn't matter. Some way you need to find what that least common denominator is, or least common multiple. A hack again is to multiply them. That'll always work. It'll always work, but it may require more simplification in the end. You'll end up with bigger numbers sometimes, not always. Now let's change, since we can't change the fraction, we have to make an equivalent fraction. We can't change the dynamic value of that. So I multiplied 3 by 4, so I have to multiply the top by 4 also. Just jot down what we did so you can see. 4 over 4 is 1, so there's my multiplying by a fraction of 1 to get an equivalent fraction. Same thing here. 4 times 1, 2, 3 is how I got to 12, so I got to multiply both top and bottom by that 3, so that I'm multiplying by 1 ultimately, and so that I get an equivalent fraction. So 3 and 4 12s plus 2 and 3 12s is considerably, is actually in the end the problem is not bad at all. So 3 plus 2 is 5. When we add fractions now with common denominators, add the tops, and the bottoms remain the same. So there's a good, clean final answer. Now let's take a look at a subtraction problem, which procedurally, the only difference is you're subtracting the top numbers of the fraction at the end and subtracting the whole numbers. Other than that, the procedure will be identical. So we're going to take the fractions, or the mixed numbers, 4 and 2/5 minus 2 and 3/10. A mixed number is still a fraction, by the way, so I keep seems like I'm misspeaking, but it's just a form of a fraction that again is easier to communicate. When we're trying to communicate what we mean by a value of something, mixed number is easier than in the alternate form, which is improper fraction. So let's go ahead and do this. We run into the same problem. 5 and 10 are not common denominators, so the first thing I'm going to have to do is create common denominators. So I like to do that this way. Your teacher may have shown you a different way. That's fine. Do whatever way works for you. So I need to find the least common multiple of 5 and 10. If you've done enough of these, then it jumps right out at you that it's 10. If you haven't, then you may have to list multiples, and you'll see right away that you find it. You can also apply the hack here. 5 times 10 is 50. But as you can see in this case, we're going to end up with a much bigger fraction than we would have this way, and we'll have to simplify more when we get to the end. So let's change. We need to create the equivalent fraction. We multiplied 5 by 2, so I've got to multiply the top by 2. So 2 times 2 is 4. 4/10 is equivalent to 2/5. Don't have to change this one because we didn't change the bottom. So the equivalent fraction is it. So now we're ready to subtract. Let's check to see if we can do this without carrying, and we can. Lucky there. So 4 minus 2 is 2. 4 minus 3 is 1. And the denominator stays the same when we add or subtract. So we have a good, easy final answer. If we had chosen the hack, 5 times 10 is 50, when you got to this point, you would have just had to, if the teacher requires it, you would have had to reduce that final fractional form or simplify it a little bit more, so there would have been more steps. That's it. Go practice.